at your notes here. So we are starting with basic parametric equations today, basically writing your normal equation with x's and y's in that third parameter with a t. Okay, so we're going to figure out how we can do that and how it looks when you do that. So we have, well, my symposium worked. Slowly. So guys, you're used to seeing y equals 3x plus 1. You're used to a table. You're used to a graph, right? That's all very basic. You've seen that before. The new way you're going to learn how to represent graphs is parametrically. We use t most of the time with our parametric equations because you usually talk about something as a position of time, and so t makes sense. On your calculator, if you guys have your calculator out, hit the mode button. We will do a few things with calculators in this unit. Exciting stuff. So once you have your calculator out, guys, go ahead and hit mode and pick para. It should be in function right now. Para, that stands for parametric. And then if you go to your y equals, you'll notice it's no longer just a y equals.
What do we do?
Mode and pick para for parametric.
Or para.
Yes, or para.
Para, okay.
So that.
And then when you go to y equals, do you see how it's not just a y anymore? It's an x and y, and your variable is no longer an x. If you hit the little x key, it would be a t. Kind of like when we picked polar, how it give you a theta instead, and we had r. So just another mode here. So let's do a very basic one here. You don't need your calculator for this. Let's figure out what this equation is going to look like. So I'm giving you the equations here, x equals t and y equals 3t plus 1. We're going to fill in this table. And this is like what you think of for your window now when you're graphing. See how it says t is from 0 to 2? That means I only want the section of the graph between 0 and 2 for your t values. So on the table, the only t values I plugged in are 0, 1, and 2. Okay? So let's just figure out what we get. What do we get for x when t is 0? Okay, what do we get for x when t is 1? And when t is 2? That was easy, right? All right, what about for y when t is 0? What do we get? Okay, when t is 1, 4, and when t is 2. Okay, so we're going to go over here on our graph, and I am going to plot 0, 1. Now I'm plotting, this is still my x and my y for how I'm plotting these, okay? Then 1, 4, and 2, 7. You okay, John? Okay. All right, I'm going to connect those. Now, do you think I want to extend beyond the points I have plotted? No, okay, because that would be more t values than we want. You do need to show direction, though. When we're talking about parametric equations, your graph is going in a certain direction. So when I plugged in 0, I got this point here, right? So this is like my starting point. You need to show that that was sort of the initial point, and this is your terminal point. So you're going to put a couple of little arrows on here just showing direction. So like a little arrow in there and a little arrow there. Okay. And again, this was a basic one. X is not always going to equal t. That's very simple when x does equal t, but it won't always equal that. And that's your graph of a parametric equation. Pretty simple. Okay. Let's just practice it on your calculator so you can see with a basic one what you're doing. So go ahead, make sure you're in parametric mode. Then go to your y equals. For x, put in t. For y, put in 3t plus 1. No, so you know the variable key on your calculator? Maybe. So And then guys, go to your window and change your window to these values as well, so you can practice your window a little bit. Once you have your window changed, go ahead and take that. What? Yep. Yeah, to make all of this happen on Windows 25. You should get exactly what we have. Uh-oh. Okay, so you have to see
No, not flashing.
Anybody else calculator? Oh,
Just
all right, guys. So let's look. I guess you don't have to turn the page. It's just on the right side of your paper. That's the exact same. Oh no, different t values this time. So guys, go ahead and graph this one for me. I'll let you practice. Graph by hand. Check with your calculator. So start with like so whatever negative one was. Okay. When we graph it, it'll actually like yeah. We don't go over those in classes. We just go one more time. Oh, yes, absolutely. Oh, yeah, I can tell you. I actually keyed them in last Friday before spring break.
I try to forget about my grades and then just like come back to school.
Just put it out of mind.
Yeah, exactly. That's a new quarter.
It is a new quarter. You got a fresh start here. All right, guys. Anybody issues with this graph? Is this super easy so far? Yes. We like this. Good first day back from break. Yes.
Oh, okay.
So you could start by. It's not technically negative time. T might not even be time. It's just the T that we use. So when we get into the word problems like the projectile motion, stuff like that, you're not going to have negative time. But with these, it's just a graph. It's not truly time at this point.
And how to apply it.
Yeah, we're gonna do some like, you kick a ball at a 30-degree angle with an initial velocity of this, you know?
Yeah, okay, good.
Just or like, you hit a baseball. Did you hit a home run? Here was the launch angle and the initial velocity and all that stuff. So you'll get some like that before the physics unit. Yeah. It just that way everyone has the same graph. Yeah, like why is it 7.05 instead of just 7? It doesn't matter. Yeah, it's not a big deal. Like if you did negative 10 to 10, negative 5 to 5, you would totally still see the whole. All right. Let's look at the next section here. Okay, guys, so we are going to, all right, guys, listen up. You're now given just a normal equation, y equals 2x minus 3, and I want you to turn it into parametric equations. So you have to figure out x of t and y of t. This is not really hard to do because the most basic way to do it is just to let x equal t. So if x equals t, okay, what do you think y is going to equal? Y of t. 2t minus 3. All right. That's it for turning it into parametric equations. That's a very basic way to do that. Again, it's much more interesting when we actually get to the word problems and you can see like what x and y represent instead of just, all right, x is t. You know, there's no context with these, so we'll get the basics down first. Yeah.
How can you check that to make sure they like add up to the original equation?
So you can graph your parametric, and then you could also just think about the graph of this. And is it the same thing? The difference here, this one would go from negative infinity to infinity, whereas this has a very specific like section of that graph. Okay.
Yeah.
All right, guys. So we are going to graph. Well, we'll fill out our table first. The x's are easy, right? 0, 1, 2, 3. What are you going to get for your y values? When t is 0, what do we get? Okay. When t is 1. 1. When t is 2. When t is 3. All right. Everybody's okay with that? Right? Okay, let's plot our points. So 0, negative 3. 1, negative 1. 2, 1. 3. Should I count right? I did not count right. Oh, John. On our recording. All right, guys. So we're only looking at that little section of the graph. That's a piece of this linear graph. Okay, and we know which direction it's going in, and that's it. You've graphed the parametric equation. Again, you could check on your calculator. Why do you think this has 3 numbers now? So this is your minimum, this is your maximum, this is like your step, what you're going by. Okay, this is the min max, and you know where it said like X scale, X SCL. It's just what you're counting by. It's not a huge deal. Usually you're going to leave the t step as the decimal that it gives you. Okay. All right, so guys, you try graphing B. So write your equations, fill in your chart, make your graph. here.
Yeah, that's already.
The team is 0. 0, 3, and then 0.2. Yep.
So the second thing is discussion. Give me a third thing.
Yes. It's like, second thing is the math.
Okay.
All right, guys, I'm going to start filling in your table here. I guess I should bring your equation. All right, guys, take a second here. Look at your graph. Is that what you got? Does it make sense that it's parabolic in shape?
What?
Yeah, when you look at your original graph, you would expect this to be a parabola. Questions so far, guys? Any struggles? All right. Let's look at the next section. All right, so the first part here, it says change your parametric equations to rectangular by eliminating your t. So what you're going to do here is basically solve for t, and then you can substitute that into your other equation. So if I look at this first one, would you agree that x plus 7 equals t? Does that make sense to you for the first one? Okay. Then I can plug that into my second equation. 5 minus 2 times x plus 7. So y equals 5 minus 2x minus 14. So what is my actual rectangular equation? Y equals not minus 16, 9. It's the adding and subtracting. Alright, so y equals negative 2x minus 9. Does that make sense? Okay. You guys try the second one. Yes, you'll have to plug a fraction in. I know you can do it. Alright guys, if you're putting it in slope-intercept form, did you get y equals negative 5 halves x minus a half? Any algebra struggles along the way there? Wait a second here. Okay, guys. When they're written in parametric form, you can actually figure out the point and the slope from your graph. Remember point slope form? Yeah. Okay. So if you look right here, if t equals 0, what does x equal? -7. Okay. And in this equation, if t equals 0, what does y equal? 5. Okay. It's not a trick question. It should be easy. So that means the point from your point slope equation is -7, 5. Like that will be a point on your graph. So our point. Yeah, or you can just look at it. Your constant term from the x equation and your constant term from the y equation, those are going to be your ordered pair. Like together they make the ordered pair. Which is the same as putting it in. All right, guys. So letter B. What is the point from our graph here? 3, -8. That's it. And guys, you can also pick out the slope just by looking at your parametric equations. Slope is change in y over change in x, right? Okay. So that means I'm going to look at the y equation first. Do you see how -2 is like slope on your y? So that's the change in your y. And then the 1 would be the change in your x. So slope is just -2 over 1. And we found that by coefficient on t in y over coefficient on t in x. Okay, so that's change in y over change in x. And when you wrote your equation, that's what you got as your slope, right? Okay. So if you do the coefficient over coefficient for the second equation, what's the coefficient on t in your y? Sure. So coefficient on t in your y is 5 over coefficient on t in your x is -2. And that does match with the slope that you found right here when you did it algebraically. Okay. So when I asked you to convert to rectangular, I could also, instead of doing it in slope-intercept, you could do it in point-slope. So you could just find your point and your slope and write your equation that way. Point slope. So we're not doing this, so we'll squeeze it in down here. Well, just that describe part we're doing. Point slope form. Y minus y1 is m times x minus x1. So like for letter A up here, if I wanted to do that, I've got my point, so I do y minus 5 equals -2 over 1 times x plus 7. Like that would be an acceptable way to write that in rectangular form. If I don't tell you it has to be in slope-intercept, then you can leave it like that. So the second one, my point was 3, -8, so I'd have y plus 8. And then my slope times x minus 3. Is that coming back to you at all? Algebra 1? Yes, good. We remember Algebra 1. Did you say you failed Algebra 1? I was like, how did you get here? Got an A. Okay, good. I would assume most of you got A's in Algebra 1. Close. All right, guys. Still good so far?
That was the last time I used to practice.
Okay.
Yeah, I just remember it so vividly. This was the last time it happened. It was right before winter break.
What was the topic?
Was it don't remember. I just remember that it
Remember
was
the-
right before, it was the
The
day.
elation of like going on break with a perfect test.
Yeah, it was so nice. And I came back. Should never happen again. That winter break ruined me.
Oh no.
No, that was the winter break of 8th grade.
All right, guys. So here's a little more, just another formula you can think about when you're writing these equations, and hopefully this makes sense. Like if you're given two ordered pairs here, look at this. Isn't this the formula for slope y2 minus y1 over x2 minus x1? And wasn't that where slope came from, like coefficient for t and y, for t and x? And then this is just the point. You could honestly use the x2 and the y2, it wouldn't matter. Okay, it's going to be the same either way. So let's try to do letter A here. So do you want to use the 0, -2 or the 3, 3? 0, -2, okay. So that means x of t is going to start by equaling 0 plus something, and y of t is going to start off equaling -2 plus something. Right? Easy? Okay. So then the coefficient for t in our x equation, we just have to do x2 minus x1, so that'd be 3 minus 0 times t. And for the y's, y2 minus y1, so 3 plus 2 t. So you could make these a little nicer. X of t, that's just going to equal 3t. And y of t is going to equal, what, 5t minus 2? All right, try B. Some allergy troubles.
Yeah, like I had to go to like the back
And just sneeze.
I stayed really far away from her. I was just sneezing the whole time.
So you got a lot out of that tour. Then.
Yeah, I don't know. I was so angry. I couldn't go.
All right, guys. If you use the -6, 1, so you'd have -6. So x of t should equal 16t minus 6. And y of t equals 4t plus 1. Okay with that? Anybody use the other point? Yeah? That's good. So you had... This is what you got second. 16T. Yeah. All right, guys. So not too bad with all your point slope and plugging things in. It's going to take a little bit of practice just for you guys to kind of get those ingrained in your head. Try to think your way through it. Hopefully it makes sense. Like think about the slope and finding the change in y and the change in x. And so it's not just a straight memorization for you, but you understand what's happening in the problem. Okay, and now we get a word problem. We get a classic 2 trains leaving 2 cities kind of problem. So, I'm going to give you a second here to read this. I don't feel like I need to read to you, so take a minute and read.
Why wouldn't it be T plus 1?
So it's leaving an hour later, right? So its time is actually 1 hour shorter, like it's 1 less hour that it's traveling. You could write it the other way, and you could say this one is just 55t, and you could call this one like 50t plus. Sorry. Yeah, plus 1. Okay. Because it's traveling an hour longer, sort of thing. So guys, the first thing we're going to do is look at this on our calculator so you can sort of see what's happening. So I'm going to see if my SmartView calculator will cooperate. When you're keying this in, we have an x component of 50t and then the 55t minus 1 for the other. The y component, does that make sense that we're just picking 2 arbitrary numbers here? The trains aren't moving vertically at all, are they? Yeah, they're just staying on the track, moving east to west. That's all we're seeing, or west to east, whichever way we're going here. So the reason we're picking 2 different y values is so when you graph it, you can actually see the 2 lines going across your screen. Okay, that's all. So let's see. All right, so the first one I'm going to enter in 50t. Does everybody understand where the 50 is coming from? I know they're telling you the equations, but do you understand it? It's just the speed that train is traveling. And I'll put a 1 in there. And then the second equation, 55 times t minus 1. So that train is traveling faster, but it's leaving the train station later. The 2 in the front. Okay. Let's go to your window. Do you guys see that it gives you your window values? So your t, it tells you to go from 0 to 17. And let's see, 0.25 for your step. And then your X-Men, we're going to go 0 to 850. Why do you think we're doing 0 to 850?
That's how far you
Yeah, and so it's like we're starting at 0 and traveling the 850 miles to New York. Now your scale here, it says 50. What these scale things do, like the T-step and the SCL, the scale, when you're tracing, that's what you're going to be able to like jump. Each little tick mark is going to be 50. Each T interval that's put in is 0.25. So it's going to, that's as you're going along, that's what's happening. And let's see, then your Y-min, they said -2 to 4 with a scale of 1. Okay, so let's watch the graph. Okay, one train, two train. You can make it go in simultaneous mode just so you can see like, oh, the one train does overtake the other, but to actually calculate where that happens, the simultaneous mode doesn't really help you much. It's just visually you can see them like going on the track together. That's it. It's interesting. So let's look at our questions here. It says, how long until the second train overtakes the first train? And it says first to answer the questions by tracing the graph. So let's go ahead and trace. We can look. We know it's not going to be in the first hour, right? Since one train has left. It's sort of just guessing and checking here. You're just going along. I don't know, I would check it maybe like 6 hours and see where we are. So this first train has gone 300 miles in 6 hours. The second train, do you guys see when I jump tracks, see how that one's still behind? It's only gone 275 miles. So then I'll arrow over. I did trace. Okay. So let's do 9 hours. This one's gone 440 miles. The first train has gone 450, so it's still ahead. So let's keep going. Let's check like 11 miles. So that's gone 550 miles. Ooh, and train 2 has also gone 550 miles. So what does that tell us? So after 11 hours, train 2 catches train 1, right? Okay. So, yeah. Yeah, so tracing on your calculator is really just like, all right, let's just trace a little while and see what happens and keep going back and forth until you find it. We're going to do it algebraically too, so I'll show you that.
So at this time, like for A, question A, when it says how long until the second train overtakes the first train, so are we saying this is where it overtakes it?
So the way I wrote my answer is at t equals 11 hours, train 2 will catch train 1. So you're telling me, like, I know that's exactly where it happens. So any time after that is when train 2 would be ahead.
Okay.
Okay. So yeah, the wording of the question there is a little bit. You could put that in the decon. Yeah. All right, guys, so then part B, it says, how far are they from Chicago when this happens? Well, at t equals 11, what was our distance? 550. Now, you have to think about it. They started in Chicago, right? And they're going to New York. Okay, so it is 550 miles from Chicago. What if I had asked you how far are they from New York? 300. Okay, so just be aware, make sure you read the context of the problem, like what am I actually asking you? And then it's for part C, we can still look at this on our calculator. How long will it take for each train to reach New York City? So that is basically just asking you how long until it gets to the 850 miles. So just keep tracing. Let's see, I'm on train 2 now, right? So I'm looking. So at 16 and a half hours, I'm at 852.5, right? So an answer I would take on this, if I'm just having you do it visually from your calculator, I would say just under 16 and a half hours. That's fine. And so then what are you going to do for train 1? We'll just keep tracing, right? Oh. And it did the trip in exactly 17 hours. Does make sense if they're going 50 miles an hour. And we'll do this algebraically too. I'm just showing you graphically here what it looks like. So for part D, how long was the second train in the station at New York before the first train arrived? Well, it got there in just under 16 and a half hours, and this one got there in 17 hours. So what do you think? Just over half an hour, yes. And again, we can algebraically figure out exactly what it is, but. All right, part E here, I'm going to have you mess with this on your calculator. It says change the speed of the first train to 51, 52, 53, 54 miles an hour, one step at a time, because we're trying to figure out when the two trains will reach the station at the exact same time. So start plugging those in and see. This will take you a little bit of time, I know. So you're changing your x1, okay? Any thoughts yet, guys? And it might not be exactly one of these miles per hour, but you can tell me in between which two. What'd you guys come up with? You said between 53 and 54? Anybody else? Close to 52. Yeah, I had written down between 51 and 52. That's like just like that. All right, guys, so let's go back and look at some of these algebraically now. Are you guys getting between 51 and 52? 52 is just a little too fast, 51's a little too slow. Yeah, okay. All right, so let's do part A here. Algebraically, how long until the second train overtakes the first train? What I'm looking at there is how long until they equal each other, right? Until they're at the same distance. So algebraically, you're just setting 50t equal to the 55, and I'm going to distribute this, make it 55t minus 55. So if you solve that, negative 5t equals negative 55. T equals 11. Isn't that what we got from our graph? 11 hours, yeah. And then how far are they from Chicago when this happens? Well, we know they've been traveling for 11 hours, so what do you do with that 11? Plug it in. And I don't care which equation you plug it into. The first one I think is easier. You would just do, so x of 11. So that's going to be 50 times 11. And we get 550 miles. And again, with these, they're not super tricky, but make sure you're reading the question and actually answering what I'm asking you. Okay, just be very aware of which direction you're traveling, all of that. Okay, how long will it take for each train to reach New York City? So we did that graphically. Algebraically, what distance do they have to travel? 850. So you are just setting each equation equal to 850. So for the first one, you get t equals 17 hours. That one's very straightforward. This one, you would get a decimal. It comes out to what, like 16.45, I think, which we said just under 16 and a half hours from our graph. All right, then D, how long was the second train in the station at New York before the first train arrived? So if we said a little over half an hour. If we're a little more specific here, looking at the differences, 16.45 to 17, how long is that? 0.55 hours. So couldn't you do 0.55 times 60 minutes? And you would get about, I think it's 33 minutes. And again, we said just over half an hour from our graph. Alright, then this one we just did on our calculator. We said between 51 and 52. Alright, so we're okay with question 4? All of those pieces? We just have one more. Okay, so question 5, we're going to change our equation to show that the second train is leaving New York and heading towards Chicago. So now they are going in 2 different directions. Okay, so our first train is still, we'll just go down here. So train 1, we are leaving alone. X of t equals 50t, and we'll still do like a 1 for y of t. Train 2, we have to think about a little bit here. That can still equal 2. So the first train is starting in Chicago and going to New York. How far is it traveling? 850 miles. The second train now is starting in New York. We can think about it's going backwards. So it's starting from 850 and trying to get back to 0. Does that make sense? So your equation is going to be 850 minus your original equation, the 55t minus 1. Because it's still leaving an hour later, so that hasn't changed. The speed hasn't changed. But that's showing that it's traveling in the opposite direction. Just like on the x-axis, it's now going in the negative direction. Okay? So now that you have your equations, try to figure out part A. And once you know A, B isn't too hard. Graphically, you'll get, in between certain hours. Algebraically, you'll get slightly more exact.
Oh, I see. I was trying to figure out
All right, guys, what did you come up with for how long until the two trains meet? Okay, yeah, I had 8.6 written down. That equals 8.6 hours. So if you looked at your graph first, you'd figure out it's between 8.5 and 8.75 hours. Everybody okay with that? Yeah? No? What happened? Yep, okay. That's what you should do. So I'll go down here. I've got a little, so 50T. You maybe didn't distribute your negative because it'd be minus 55T and then plus 55. You had that? Okay. So if I add my 55T, I'm at what, 105T? And this would be 905.
Oh, I'm sorry. I was subtracting.
Oh, okay. All right. Okay. And then how far is each train from Chicago? Again, we're saying from Chicago. If I'd asked you from New York, it'd be a different question. So I would just plug that 8.6 into your train 1 equation, and you should get, what, was it about 430 miles? 430 what? 1, okay. Yeah, you can plug it into either one. I'm just saying if I'd asked you from New York, it'd be a different answer. Because it's 850 miles total.
But they're the same spot.
Right, so you could plug it into either equation to see from Chicago. But I'm saying if I had asked you from New York, you'd have to think about it a little differently. Because like, this equation is telling you like from Chicago to the other thing. Okay. Gina?
So when I plugged in 8.6 into both equations, I got 430 and 432.
Okay, it's just because the 8.6 isn't exact. Yeah, that's all.
So just pick it up with
Yeah, either one is fine. Yep. Okay, questions? Easy day 1 of notes? Okay, so your homework. Stop the recording here.